I can't tell you enough how much I love math memes. So please, please, please do send them. Josh L, it is okay. Don't worry about it. Let's get this done. Josh, if you want to come back, Josh L, if you want to come back at 10:30, we can also go over it. If you have Spanish, then we can come back at 11:20, whenever. Cool. Thanks, Josh. Thanks for checking in. So you got 2 math memes here. Today we're working on assignment 25. Miss Yama already hit you with the attendance link, and we are going to jump in today with some announcements. Cool. First announcement is this: Los Angeles Urban League math support. So you might be thinking, what is Los Angeles Urban League? The LAUL is a local organization that works to uplift and empower Black and Brown communities. They offer a lot of different like services and programs. One is a high school mentorship program. They do like college tours. They offer some scholarships. And then one is really awesome, which I'm highlighting today, which is math tutoring. It is very cool because it can do any level of math. So y'all can take them your pre-calculus, or if you have a little sibling that needs to like get some help on 4th grade math and you don't know how to help them, or you want them to have like a different kind of help, you can also have them do this program. It's on Tuesdays, Wednesdays, and Thursdays from after school from 3:30 to 5. And here's the best part. In addition to getting math help, which is already pretty cool, if you go and get help, they also pay you in gift cards. They pay you a $10 Walmart gift card for every week that you go, which is cool because like you can get $10 this week and $10 next week and $10 the week after. So you like can get your math homework done. You can get any help that you need and you get paid, which is kind of cool. It's like having a low-key job. It's like school paying you. I'm going to draw the way that you get like involved is by filling out this form. So I'll drop it here just in case you are interested. So the tutoring link is there, and that you'll sign up on that doc, and then Batisi will put you in like involved, or she'll like connect you to the organization. So very cool. Are there any questions about doing math and getting paid? That sounds awesome. It kind of sounds like my job, to be honest. I do math and I get paid. It's awesome. Kaylin, you have a question? Oh, okay. Yeah, fill out this one. Do math, get paid. It sounds like a fun time to me. Cool. That's my like major announcement for today. I wanted to get our brains thinking around some of the things that we're going to be working with today. So here's the situation. I have 4 situations and I will zoom in on them in a hot second. We're going to be thinking about the question, what do you notice and what do you wonder about these 4 situations? Let me try to, nope, don't do that. Come on, zoom, there we go. Okay, so these are the 4 situations. I typed in these 8 different things on Desmos to get the answer. So we have this one and this one I typed in together. They both equal 3. This one and this one I typed in. They both equal 2. This one and this one I typed in. They don't equal each other. And this one and this one I typed in, and they equal this decimal. Right? So I want you to think about what is something you notice and what is something that you wonder. So you can do either one, notice or wonder, right? Notice or wonder. What do you notice? What do you wonder? And you can reference the different situations by situation A, B, C, and D. So if you're specifically talking about D and you notice something about D, you could say in situation D, I see, or I notice, right? I would love every person to type a chat to me. You can private message if you don't feel confident sending to everyone. Everybody send me your notice and wonder. I'm going to be quiet for about 30 seconds so you can send me your notice or your wonder. Thank you to those people who've already sent me your notice or your wonder. Got 6 so far, 7 so far. Something you notice or something you wonder. If you're just jumping in with us, we're thinking about something we notice or something we wonder based on what's on the screen here. Something you notice or something you wonder. We have some amazing noticings and wonderings here. Amazing noticings and wonderings. All right, I would like to invite 5 people to come off mute and say their noticing. 5 people is what I'm looking for, just so we can understand your noticing so far. 5 people, feel free to jump off when you're ready. Come on, you can do it. 5 people. I know it's early in the morning.
Okay, so for situation C, I saw that the bases weren't the same when they were being added. So the base for log 29 is 2, but for the other one it's log 3. And I think that's why the answer is different from log 327.
Amazing notice and wondering. Thank you, Jimmy. Appreciate you. All right, we've got 1. We need 5. We need 4 more.
Okay, I noticed that in situation A, they have the same logs, and then when it's addition, it seems like they multiplied them to get the 27, and then it equals 3. And then in situation B, it's subtraction, and then they have the same log base, and then they divide it to get 4.
Wow. Thank you, Diana. Taking on 2 situations here. Appreciate you, Diana P. All right, we've got 2. I have so many beautiful notice and wonders in my chat. I would love to hear them out loud.
Adding to what Diana said, with the multiplying in situation C, they multiply to 27, but since the bases weren't the same, they're different answers.
Thank you, Christine. Highlighting that different base there. All right, we've got 3. Looking for 2 more. What about situation D? Did anyone notice anything about situation D?
In situation D, the 8 has the square root of 3, but in the bottom one where it's 3, the 3 is in front of the log, but they have the same answers.
Yeah, Diana, absolutely. I want to highlight one thing that has an exponent of 3. It has an exponent of 3. So when it has an exponent of 3, it looks like that's the same as putting the 3 in front. Absolutely. Absolutely. All right, we've got 4. We need 1 more. Anything else that we notice here?
I want to add on to Diana for situation D. So they have the same base, they have the base of 8. But like the only difference, like kind of like she said, is that the exponent is 3, but then on the other one, the 3 is in front of the log.
Yeah, absolutely. They do have the same base. I would mention the base is 10, right? The little base number is 10, but that number, as you were saying, Mia, right? Then they have the same number 8, right? And so they have the same base, the same number. It's just that 3 that's many. For sure, for sure. Yay, we reached 5. I also want to highlight there were a few wonderings. I wonder if the equations of situation D could be combined or if they have to be in the same format. So I really love that wondering, right? So like, can we combine these or do they have to be like exactly the same as these other ones here, right? So today we're gonna be looking at log rules, right? So that question really launches us into a good place. We're gonna be thinking about combining and separating logarithms. So let's just check in real fast. Let's go ahead and take a look at our notes. All right, we're going to take a look at our notes. I realize that I have an old version of this, so I'm going to go ahead and pull up the notes to show you here. And I'll go ahead and put these notes in the chat as well. Amazing noticings and wonderings, everyone. I love all of the noticings that came through. Great job. We're going to continue practicing this. This is what mathematicians do. They notice things and they wonder things. So you should have a document in front of you. You might have made a copy already. We're going to do this portion together on the computer here. So I put the 4 situations that we were just talking about, and I just want to summarize what we were having here. So when we have logs added together, right, logs added together, we noticed that we could go ahead and multiply them together. So what I would do, I'm going to go ahead and enter an equation here. So I have log base b. Y'all notice that the bases needed to be the same. And when we have that, we have m times n, right? So when they are being added together, we have m times n. The same is true for natural log, right? So if we have a natural log here, right? So natural log a plus natural log b, this would be natural log of a b. Just a times b. So I can write it with the times symbol, or I can just write them next to each other, since mathematically those two things mean the same thing. What did we notice? What did Diana pull out that we noticed between 32 and 8? What did Diana notice that we do when we have subtraction of logs? What should we do with m and n? Yeah, Christine, absolutely. We should divide, right? So we're going to have, instead of having just m, we're going to have here a fraction. It will be m over n. I should put those in capital. M over n. Like this. All right. Can someone tell me then, what would the natural log version be? What would the natural log version be? How could I combine these together? Yes, absolutely, Fatima. So we'd have the natural log of a over b. A over b. I want to highlight one thing, which is that some people will put parentheses around a and b like this, and they'll say the natural log of a and b. Some people will not put parentheses. That is a personal choice in most cases, right? So personal choice here. All right. So you could write it just like m and n, like we did on that first one, or you could put it in parentheses. Either way. When you're typing on the chat box, it's probably best to put it with parentheses. So if you were going to write this in the chat box, you would probably put natural log of a divided by b like this. So because this ln a divided by b could possibly also be interpreted as like ln a over b, like that, right? So there are like different interpretations of how that might be written. So this one is the most clear, where you have the parentheses around a and b. Okay, so using parentheses is super helpful for telling us what is being applied here. All right, so that was situation A, we multiplied. Situation B, we divided. What happened in situation C? I don't know who called this out for us. I think it was Jimmy called this out for us. Why are these not equal? It's the only set that's not equal. This doesn't work because what? The bases are not the same. Absolutely, Christine. Right? The bases are not the same. So since the bases are not the same, it doesn't work. For sure. And then finally, we had this last situation here where the logs were multiplied. And Mia and Diana were talking to us about this one. What did we do with the exponent? Where did the exponent go when we tried to simplify this, when we multiplied? What happened with the exponent? What are we allowed to do? Yeah, Diana, we're allowed to put it in front of the log. So I put n log m, like that. So we're really taking that exponent, is multiplying it, becoming that coefficient in front. The coefficient in front. So these are the 3 rules we're going to be reworking with today. When we have logs added together, they multiply. When we have logs subtracted, they divide. And when we have logs that have that exponent, they're multiplied in front, right? Multiplied in front. So we're going to do a few examples together. They will look like this: evaluating and compressing. If you want to continue typing on your version of this document here, that's great. I personally write much faster than I type in math language. So I'm going to switch over to my iPad to work through these problems together. Well, let me go ahead and stop sharing. If you need to find a pencil and paper at this time, feel free to do so. If you're already ready, it won't take too much of your time here. Just switch this over. Here we go. Cool. All right. Can you throw a Y in the chat if you are ready? Y for yes, you're ready, or N for no, you're not ready. Cool. I've got like 15 Ys, which is great. All right. If you're not ready, it's okay. Keep getting ready. For right now, we are going to expand and compress. When I say the word expand, why am I making my hands go out like this? What do I mean by the word expand? Spreading, yeah, spreading, or like making bigger, right? I'm thinking expanding, like when you put water in the freezer, it expands to become ice, right? It expands. And then we also have compressing, or another word that we might sometimes use is condense. Compress or condense. Why are my hands going in when I'm condensing? What does condensing mean? Simplifying or getting smaller. Yeah, absolutely. Yep, simplifying, getting smaller, for sure. So we are either going to take one log and make it multiple logs, or we're going to take multiple logs and make them one log. Okay, that's our goal. So we'll start with expanding, start with making things bigger. So I did this first one for us. So we'll walk us through it. So we have log base 3 of x times y squared, right? So the first thing that happens is I'm going to notice that I have 2 variables. And since I have 2 variables, that's how many logs I'm going to expand it to. So I have my x and my y. I notice that x and y are being multiplied together. That means my logs, when I expand it, are being added. So multiplication, remember the rule, turns into addition, right? So I have log base 3 of x plus log base 3 of y squared, right? So I expanded those into my two different variables. And then I'm going to take the exponent 2 and I'm going to move it in front. And that's how the 2 ended up right here. Right? So my expanded form would be log base 3 of x plus 2 times log base 3 of y. This would be my expanded form of that equation. So if I'm going to think about this one, I'm going to go straight down here to this one here. I have the natural log, remember, same rules apply with natural logs, the natural log of AB over C squared. I have A, B, and C. How many logs are going to be in my expanded version if I have A, B, and C? Yeah, I'm going to have 3, one for each of my variables, one for A, one for B, and one for C. So you might think like, oh, but there's A, B on the top and then C on the bottom, right? So that might be why you're thinking 2. But since there are 2, like in this case, we had X and Y both on the top, we're going to separate those apart. So we're going to separate A, separate B, separate C. So I'm going to go ahead and write the natural log of A. It's positive since it's on the top, plus the natural log of B, also positive since it's like being multiplied on the top. And then I'm going to put minus the natural log of C squared, right? Minus that natural log of C squared. Why is C squared on the bottom? I'm sorry. I totally didn't ask the right question. Why is C squared subtraction? Why is C squared subtraction? Why is that natural log subtraction rather than addition? It's at the bottom. Yeah, I answered it in my first question. It's division, right? So when we see this division here, this is on the bottom. That's going to mean subtraction. We're dividing. And remember, our division rule is subtraction, right? So I have this one here. And then how can I simplify a little bit further? There's one more step.
We put the 2 up in front of the inverse of C.
Yes, we can take this 2. We're just going to put it in front of the natural log here. We don't want to take it all the way to the front because it doesn't apply to the A. It only applies to the natural log of C. So the 2 goes in front of the natural log of C. So we'd have negative 2 natural log C. We're going to bring down the rest of this here. And this would be the expanded form of that one there. Thank you to, I think it was Diana, came off mute. Appreciate you. All right, based on these 2 examples, how are we feeling? Quick poll. Quick poll, how are we feeling? We're gonna do more examples, so don't worry about being a 1 or a 2 or 3. Just wanna get a quick gauge. Who's out there? Who's still listening? Awesome. Cool. Feeling pretty good, it looks like. So I want you to go ahead and try. Go ahead and write down both of these examples. I'm going to give you maybe 1 minute to work through as far as you can on these 2 examples. So as far as you can on these 2. All right. Anybody want to talk to us about either of these? We don't have to do one over the other. Start us with this first one. So natural log of x square root y means we have the natural log of x times, I'm going to go ahead and put this into exponent form, the square root. Does anybody remember the square root? What does that mean as an exponent? Y to the power of what?
To the power of 2.
Close. Not quite to the power of 2, but to the power of 1/2, right? The power of 1/2. Thanks, Mia. The power of 1/2. So instead of squaring it, right, it's the 1/2 power. We have this like 1 here, and we're taking the 2, or moving it below there like that. So 1/2. So I have 1/2 here, right? 1/2 there. I have x and y. How many logs is this going to have? When I expand it, how many logs will it have? 2, absolutely. So I'll have the natural log of x and the natural log of y to the 1/2 power. Will this be addition or subtraction here? Add, absolutely, Diana. Since it's multiplication, we're going to have adding. And then I'm going to take that whole 1/2 and move it out in front right here. So I'd have the natural log of x plus 1/2 times the natural log of y. So, awesome. I'm guessing that most of you all worked on this one during your 1 minute. I'm going to quickly go through this one. I have x, y, and z. So I know I'm going to have 3 logs here. So I'd have log of x to the 3rd. It's positive, it's on the top. I am going to subtract y, right? Subtracting log base y, I'm sorry, log of y. And I'm going to subtract log of z. Be careful here. Go ahead and double check your paper. I am subtracting both y and z because I'm dividing by both y and z. Right? So I don't want to put addition here just because y and z are being multiplied against each other. Right? They're both dividing. You could think of it like subtracting log y and log z like this, but then that negative is going to distribute into both of them. Right? So they both end up being subtraction. The only other thing I need to do is move this 3 in front. So I'd have 3 log x minus log y minus log z. So be careful when you have 2 things in the denominator, 2 in denominator, they're both subtraction. That would be my note from this one. All right. Talk to me. How are we feeling about expanding? How are we feeling about expanding? Yeah, so the top is addition in a way, for sure. The top is addition, right? Those are things that we're adding. And then the bottom is subtraction, right? We're dividing in subtraction. All right. All right, let's talk about condensing. Right, so I'm going to walk us through this example here. So for condensing, we're just doing the opposite direction. We're taking 2 logarithms, right? So I see that I have log base 2 of 6 plus log base 2 of 8/3. So since I have the same log, they can be written as 1 log, right? So log base 2, here's that log base 2. And since it is addition, we know that we're doing 6 times the 8/3. So 6 times the 8/3. Then I'm going to go ahead and multiply together 6 8/3 into 48 thirds. And then 48 divided by 3 would be 16. And so then I end up with log base 2 of 16. So I'm thinking, okay, 2 to the power of what gives me 16? 2 to the power of what gives me 16? Oh, 2 to the power of 4 gives me 16, right? 2 to the power of 4 gives me 16. So this whole logarithm will simplify into the number 4. So ultimately, our original equation, the answer is 4. Right? If we were to type all of this that's in the red box into our calculators, we would get 4. Wild, totally wild. All right, let's look at this one here. This one's written, the one that's there is written in your notes. So I'm going to go ahead and move it up here. Okay, so I'm condensing here. I have the natural log of x plus 2 plus the natural log of x minus the natural log of x to the third. Right? So I know this one and this one are going to be multiplied together because of that addition sign. And then I know this one is going to be divided, or it's going to be on the bottom. So I'm going to have 2 things on the top and 1 thing on the bottom. So I have the natural log of x plus 2 times x. And then this is subtraction, so it's going on to the bottom, x to the third, like that. So we have condensed them into one logarithm. And now we're going to go ahead and simplify x on top and 3 x's on the bottom, right? We can simplify by taking away, like by dividing an x here with one of the x's here, right? It's like we had x and then x times x times x, like that. And I'm going to cancel one of those x's and then left with x squared on the bottom. So this would be the natural log of x plus 2 over x squared. So this would be the simplified version of this here. I want to do one more example in our last 3 minutes here. We'll do this one here. So 1/2 natural log of x minus 2 natural log of y minus natural log of z. Why not use the other? Sorry, I'm seeing this question from the other one. Why not use the other x? Oh, why not use the x plus 2? X plus 2 is like stuck in that parentheses, right? So we can, like, x plus 2 is always going to be that number x plus 2, and the addition does not allow us to cancel it, right? We can only cancel if we're multiplying. So we have that x divided by x to the third. Those are being divided, and they are like by themselves. So if there's any addition or subtraction in the problem, you can't cancel that. It's basically like saying you could do, if it's 2 times 2 over 2 times 3, you can cancel these 2's and it will still equal 2/3. If you have 2 plus 2 over 2 plus 3, you can't cancel those. You're not allowed to cancel them. So you would have to add them together like this. Right, so if there's addition, you can't mess with it. All right, let's do this last one. So I have 3 logs. I see that there is a positive log here, a negative, and a negative. So I know that these 2, oh man, really? The second 2 are going to go to the bottom, and this one's going to be on the top. I'm going to deal with these numbers in front. The coefficients are becoming my exponents. So I have natural log x squared. The 2 going here. So minus natural log of y squared minus natural log of z. So natural log, and then on top would be x to the 1/2. Y squared ends up on the bottom because it's subtraction, and z ends up on the bottom because it's subtraction. This is a perfectly fine answer. You could, if you wanted to, write it as the natural log of square root of x over y squared z. If you wanted to, this is also a perfectly fine answer because x to the 1/2 power is the square root of x. So either way, I would accept both of these. It is 10:30, so if you need to head, you are welcome to head. I think that you should be in a good place to do your problems, but if you did want to check out the video for these 3, I've completely done each of these. So you're welcome to check that out if you're getting stuck. If you want to stick around and do some problems with me and Ms. Yamanaka, we'll be here from 10:30 until noon today, from 10:30 to noon. Other than that, love you guys. I will see you on Thursday. See you on Thursday. Adios, amigos. Bye, Kiara. Hi, Noemi. Welcome back. Hi, Shemaya. Welcome back. Bye, Jimmy. Bye, Mia. Bye, Kat. Hi, Shemaya. Hi, Noemi. Hi. Were y'all working on the homework and got stuck? Yes, let's do some homework problems together. Yeah, were y'all working together or did you just show up at the same time? You showed up at the same time. Nice. Okay, well, just a reminder, you're welcome to come off mute if you would like to. I'm gonna make this bigger so it's actually helpful. And then, cool. Okay, great, let's jump in. Shemaya and Noemi, can you tell us what questions you are working on, got stuck on? Just say what number it is, I guess. Or we can just start with number 1. Shemaya's on 8. Cool, we can do 8. Noemi, what about you? And 5, cool. Okay, so let's do 8 and then we'll jump back to 5. So for number 8, wow, my pen is like legit dying as we speak. Mechanical pencils, man. Okay, Shemaya, do you know what the square root of 100 is? It's okay if not. But since I know, so I'm thinking of 2 numbers that multiply to get 100. I'm thinking 10 and 10. So since it's 10 and 10, yeah, for sure. So then the square root would just turn into 10 by itself. So you'd have square root of 12 over 5 times 10, like that. And so then you would have square root of 12 over 50. And then I want to simplify this 12 if I can. Can we break down 12? Feel free to come off mute. It doesn't even need to be quiet.
and 6, miss?
Yeah, 2 and 6. So you do 6 and 2, right? And then 6 is 2 and 3 like this, right? So then we need groups of 2. We would have like these 2's here are coming to the outside. And then we have the 3 left over on the inside, like this. Over this 10, or over the 50. So then, now that I have that, I'm going to try to simplify if I can. Is there anything I can take out of 2 and 50? Anything I can divide out of both of those?
2?
Absolutely, 2. I can take out 2, and I can take out 2. And that's going to leave me with just 2 divided by 2 would be 1. So I don't need to write that anymore. I'm just going to write square root of 3 over, and then 50 divided by 2 is 25. So we have square root of 3 over 25. That's our answer. Shemaya, does that make sense? Oh, it's okay. Shemaya, let me know that she's lagging a little bit, y'all. That's why. Having a hard time. Okay, Shemaya, I'll leave that one on the screen. So whenever you get to it, whenever your computer catches up, you can have it. And then we'll do number 5. Let me. So number 5, 2 square root 4 over 3 square root 3. Noemi, did you do anything or did you just be like, I'm stuck?
No, I was just stuck, miss.
Just stuck, yeah. Okay, so I'm thinking like 2 over 3, that doesn't simplify, so it has to stay. 4 over 3, that doesn't simplify, it has to stay. Can you do the square root of 4? Do you know a number that the square root of 4 equals? Like something times something gives you 4.
2?
2, yeah. So the square root of 4 really simplifies into the number 2. And then we already had the 2 from before. And then it's over 3 square root of 3. What's 2 times 2?
4.
4. And then it's over 3 square root of 3, like this. And then it would be tempting to leave this as our answer. But remember that the cavemen, they don't like it when the square root is on the bottom. So what did we have to do when the square root was on the bottom?
You use like 4, radical 4.
We use whatever radical is on the bottom. Whatever we're trying to get rid of, we
So
use that same one. Say that again.
3.
Square root 3. We're gonna use square root 3. When we do on top or on bottom, we have to do on top too. So I would have 4 square root 3 over 3. This is this 3 right here. And then what's square root of 3 times square root of 3?
9.
Yeah, it'd be the square root of 9, right? But what's square root of 9? Like something times something equals 9.
3 times 3.
3 times 3, right? So it would be 3, right? So square root of 3 times square root of 3 is square root of 9. And the square root of 9 is positive 3. Right? Square root of 9 is positive 3. So we would have 4 square root 3 over positive 9. Wow, my screen's super laggy. Sorry about that. So I know that I'm done, Noemi, because 4 over 9 does not simplify anymore, and there's no radical in the bottom. Right, so 4 over 9, there's nothing I can take out of both of those numbers, and there's no radical in the bottom. Or like it felt like we were done up here, but we weren't really, because the square root of 4 can still be simplified into the whole number 2. And then it felt like we were done right here, but we weren't, because the square root of 3 was still in the bottom. So then we had to do this orange step to get rid of the square root of 3 in the bottom. Does that make sense, Noemi? Okay. Do you still have any questions? We can also do another one together.